Hello, welcome to RSC Fire Modeling. In today's video, we're going to talk about our polyurethane crib that we use as the fuel package in the reduced scale enclosures. A couple questions we want to ask when building this is the burn time reasonable? Does this represent that as a fuel package similar that we found in the full scale enclosure? Is the heat release rate appropriate? When this was tested in the cone calorimeter, it showed to be approximately 2.6 kilowatts as a heat release rate, which was close enough to a 3 kilowatt heat release rate, and that would give us the comparable 100 kilowatts in the full scale enclosure. Is the burn geometry repeatable? In other words, when we take this fuel package and we build this and burn it in one reduced scale enclosure, can we build the same type of fuel package and put it in another reduced scale enclosure and expect the same results? Does it burn the same way? Does this have enough energy in it to ignite the secondary fuel? That is, when it sits next to a couch or a chair, does it burn with enough energy that it can actually ignite that secondary fuel, just like in a full scale enclosure? And then the last one, is it easy to build? The material is readily available. You're already using carpet padding, and since the material is already there, simply cutting it up and building a little crib, you've got your fuel package. This is the result of the cone calorimeter test from the ATF, and as you can see, the morphology is similar to that of an ordinary combustible, that of a trash can, let's say. And the peak heat release rate was approximately 2.6 kilowatts. Again, if you refer back to our calculations from the other videos, a 100 kilowatt fire in a full scale is comparable to a 3 kilowatt fire in a reduced scale enclosure. So the real simple steps in building this. First of all, we take our strips that we've taken the carpet padding, which is already 1/2 inch thick, and we're just going to go ahead and cut it into 1/2 inch strips. Our fuel package, our crib, in this case, is 2.5 inches long, so we just measure our first piece at 2.5, and we cut it. Everything is measured relative to that first piece that we cut. So this was the first piece that we cut. We're going to hold it up, cut another piece, and cut a third one. This crib requires 7 pieces. Grab another strip. We're going to cut it. That's 5 pieces. We'll cut this one here as 6. And one more. So now we have 7 pieces. When we look at the strips, we see that there's the bottom piece that kind of has a net on the bottom. And when I build these, I always make sure that I put this on the bottom. So the first thing we want to do is take 2 pieces and align them in such a way. And I use any type of adhesive. I just use an ordinary white glue to attach everything. And you can use a construction adhesive or whatever you find, but just simply putting a dab of glue on the corner, that gives it its width at 2.5 inches, and we've already cut them into 2.5 inch lengths. And if you recall, again, the first one is 2, the second layer is 3. So we'll put one more in the center. And then again, the last 2 are going to go on the very top. Now, if you notice, when I put those on here, I offset them a little bit. And I actually offset them the thickness of the very first piece. So it's a 1/2 inch offset. And the reason I did that is it just came about through a whole bunch of testing trying to get this crib to burn in the same fashion. In other words, when all of the cribs burn, do they burn the same way? In other words, do they fall inward? Do they fall outward? And this middle piece here that's missing was actually discovered by accident. I forgot to put it in one of the cribs, and when I burned it I noticed everything dropped into the center, and that kept my crib from falling outward. So this little array is real simple to build, and when you use it in multiple reduced scale testings, you're able to ensure that your fuel package meets these questions here that we just addressed. So please look at the website, and if you have any questions, send me an email. Be safe and happy modeling.